You ever see anything like this before? That's pictures of distributive tiles. Let's see what this is all about. To begin with, it might help to look at this. I want to know the length of that line. Well, it's almost 6, but it's not quite 6. We also want to know the length of this line. A little more than 1.5. How do how do I put this length? Do I use feet to measure it? Inches? I said it's a little, almost 6. Or would it be better to use a smaller unit? Looks like a little more than 15 centimeters. Here, a little more than 4 centimeters. Now we could go millimeters, but that's overkill. I don't think we really need to do that. And I can't really tell with millimeters. There's no, lines in between the little lines there. I mean, you can guesstimate it, but you wouldn't be able to say it's, like right here, 4.05. Well, I don't know, maybe 4.0709. Maybe it is 4. I don't know, 4.1. So anyway, I think you understand we want to get the smallest unit there. So let me pause. Here's some distributive tiles all cut out. Nah, I didn't cut them very good. Not even close. Look at this. These should all be the same size. But you get the idea, okay? I'll put this one there, this one here. And they really should be the same exact length. Now, that might have been cut across there. Or, well, another one, They should all be the same. So just to let you know, there. But, and this should be, the same there. That looks pretty good right there. So again, these should be the same. I've cut them pretty quickly. I'm not the best with cutting these. But where I'm going with this is, what would you use for a unit? Well, you wouldn't want to use this. To use that as a unit, it's kind of hard to measure this. I mean, if this was exactly 3 of these, then we would say, okay, we could call that the unit. It's not 3, but you get the idea. I think we'll use this, the length of this side, for a unit. 1. It's not 1 centimeter. We don't know exactly what, but it's a unit. So when I ask for the total area back here, we're going to get square units. Okay, so there's that idea. Now what I would like you to do is to put all of these in order. In the most, easiest to understand, simplistic order. I don't like them scattered all over. Maybe you could take a little pause now, you and your colleagues or classmates, and put those in order, okay? Well, I hope you took a pause. I paused a little bit because I realized that it was way off and I cut it down a little bit. But again, this is not 3 across. I mean, if this is a unit, then that would be 3 units. It's not. I can turn it this way. This is a square, but it's not 3 units across there. Okay, so we got that squared away. But if we're going to call this a unit right here, this one, this little piece. That means it's got a length of 1 right here, and it's a square. So it's got a length of 1 right here. And then what's the area of it? Well, 1 times 1, 1 times 1 equals 1. 1 squared equals 1. So that has a, and we name these by their areas. So it has an area of 1. That has an area of 1. We call it a 1 square. This up here, what's the length from here to here? And if you said you don't know, then you're right. And when we don't know, we say it's x. And if it's x there, it's x here. And we know that x times x equals x squared. So there's an x squared piece. Let's talk about this one. Has a width of 1, has a length of x. Remember? Fits right along there. Should. That didn't look too good, but so here, this is x, this is 1. The area is length times width, and x times 1 is x. So there's an x squared. So we have an x squared square. Now this is an x rectangle, sorry. An x piece. And I said x squared, didn't I? And this is a 1 piece, a 1 square. We could call it 1 square, x square, and here just x. Okay? Now, I asked you to put them in order. Did you get something that looks like this? And I'm going very carefully now. Even though this better than paper kind of has some electrostatic, provides a little stability electrostatically. So I can pick this up on its side and pretty much those will stay there pretty close. But there's the order you would put them in. That's the most reasonable order right there. Okay. Now, look at this. We have a rectangle. And we have x plus 1 plus 1 plus 1 plus 1. We have x plus 4 up there. Down this way, we have 2x plus 1 plus 1 plus 1. That's 2x plus 3. I'm going to pause it right now. Yeah, I was paused for a little bit. You can see I cleaned up. I got another sheet down here. Let's watch this. I'm going to make that diagram this way. This might help for you to see how you can make it very quickly and easily. Okay, so I'm going to go across like that, go across like that. I'm going to come down like this. There's the x squared piece there, the x squared piece here. And now I'm just going to draw those x's this way. 1 over 4, I believe it was. And now here, x's down here, going across this way. And it helps if you can kind of erase a little bit. Better than paper, it's nice stuff. And there it is. Here's an x, 1, 2, 3, 4. We got 4 x's there, 5, 6, 7, 8, 9, 10, 11. Here's a 1, and we've got 12 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So what's the area? The area is 2x squared plus 11x plus 12. The area is, remember this is x here, plus 4, and here we have 2x plus 3. The area is also 2x plus 3 times x plus 4. In other words, this factors to this. Okay? Have a good day.